Hello, it's Steve here. I've not done a video in quite a while, but so bear with me. I might be a bit rusty on this one because I'm very out of practice. Not that I was in practice in the first place, but I'll try my best. What I'm going to talk about today is inputs. Now, normally you would use, say, if let's say if you wanted to like make more than one input go into one data pin, you would normally use something like a parallel in shift out register, which a common one is a 74HC595. But what if you haven't got any of those laying about and you wanted to, say, make a quick mock-up? Well, I've done like a funny little project here, just a hack. What I've done, I've got 105 of these. These are the 74HC595, which is a serial in, parallel out. You'd normally use these for outputs, as in like lighting up LED arrays and whatnot, or controlling individual things within a piece of machinery or whatever you can put your mind to, by firing down a binary sequence to the chip. Now, I'm going to tell you, you can actually, as I say, make inputs with one of these chips. Some of you may know it, or some may not know it, but I came up to a conclusion that you could. I had an inkling that could be done. So what I done, I come up with my version of it, because what I've done, I looked it up on YouTube and I found that there's a few videos out there where they make like a piano, like with a 595 chip. So what they do in their program, in the code, they turn on, like this is data pin 0 on pin 15, then you've got 1 through to 7, which are the rest of the remaining data pins. You pulse these on like one at a time, so you turn turn each one on then off in sequence, and then when you get to the last one, you go back to past the last one, you go back to the beginning, so you keep going through and through and through as you're going through your loop over and over again inside your code. Now what I've done on mine, because like I wanted pins rather than buttons. Now with the button version, you couldn't really, like, if you wanted to like turn that into pins, you would have to put a resistor somewhere between the chip and these diodes. These diodes are all common cathode pointing outwards to this row of 8 wires. These are all connected together, right? Treat these as one long metal bus that all these cathodes are connected to, and then it connects into this yellow wire here, which then goes through this resistor back to ground, and this yellow wire goes up to a pin on the microcontroller. Now the whole idea is, as you turn these outputs on and off in the sequence, each time each one turns on, it turns on its relevant transistor. What I've done is, where you would see the push buttons on the other videos, which I will link to these other videos in the description, or link to at least one of them, if I can find them, that is. Again, I'm pretty sure I remember where one of them was. Now, what I've done here, each one of these yellow wires from each output of that chip goes into a collector into each transistor, and then out of each transistor, the emitter is connected from each transistor to each diode, to each one of the anodes of the diodes. So that is to stop that's to stop more than one pin on the outputs of this chip here from getting confused with one another. Otherwise, you've got no way of telling which is which. And then what I've done here, these row of wires here are all connected to positive 5V, and they go over to the back, and there's a row of them back here, which each one of these connects to a 1 kilo ohm resistor. The resistor down the bottom here, I don't know if I mentioned, that one's actually a 10 kilo ohm. These are all 1k, and what happens, the bottom end of these, each one of these goes into the base of each one of these transistors, so that when you put one of these 5V wires onto each one, it turns on the transistor through the 1k resistor, because what you have to do, you have to limit the current going to these transistors. Otherwise they just overheat and they just go pop, or just fizzle, or sometimes just go dead. Depends like how much current you're putting through, I suppose. But what I'm going to do, I'm going to explain this. I've got a circuit diagram up here. Now what I'm going to do, I'm going to turn my spotlight off because it's saturating this area. Also what I'm going to explain as well, another reason I'm saying about these chips here as well, I paid £4.50 on eBay for these, and I've got 105, including that piece of foam here, and one of the ones off of that 5 are on this board already, on this breadboard. Now I had 5 of these, the 74HC595s, and the first one I used when I first experimented with one of these, I blew the thing. It just didn't work, and there was a funny smell coming up, so I switched it off. And then what I'd done, I then tried another one and checked through my connections. I can't remember what I'd done wrong, but I had connected something wrong. But then like the second one, I can't remember what I'd done, but I might have accidentally brushed another wire against another pin and blown it. Now I've noticed with the 595, I've accidentally touched the wrong pins on these 595 chips, and I've not blown a single 595 yet. That means these must be more robust than these. And also, the 595 is actually cheaper than these things here. Like as I said, 100 of these is £4.50 on eBay. To buy 50 of these, or sometimes even like less than that, they seem to want a fair bit more. Like I calculated on their consignment, I found consignments of 10 each on a listing, and some are like 99p, some go up further. But you think about it, you'll pay paying a tenner or more for 100 of these 165s, where you can get twice as many of these for the same price. And also transistors, general purpose transistors, are also, you can get quite a few of them for like a £5. And diodes as well, you can get loads of them for a £5. I mean, I've just ordered 300 of these for £3. These GP diodes here. Can't remember what the number was on them, but they're just general purpose diodes, rectifier diodes. Now the way this works anyway, I'm going to get back to the way it works. When you live up, or put a positive 5V to this side of any one of these resistors, the one which you provide the power to will connect to whichever one of these transistors it connects to. It will then turn on this transistor, which will then pass current to this diode onto the bus, and then up this yellow wire, which is connected together here because I ran out of, I haven't got any longer wires, so I've gone back to here, on here, to this pin 5 on the microcontroller. Now these other three wires, the blue one is the clock wire, which goes to the clock pin on the 595. The white wire is the latch pin, the green wire is the data pin. So what I'm doing, I'm in my piece of code, I'm actually putting the number 128 into it, LSB first, like this lowest significant point first, bit first I mean, and then what I'm doing, I'm using a bitwise shift to the right, So 128 shift 0 is 128. So I've got a loop that goes from 0 to 7 in the code, which I'll show you in a sec. And what it does, it starts off at 0. You get, obviously, 128 shift right 0 is 128. The same thing, shift right 1 is 64. Shift right 2 is 32. Going on and on. So it goes 32, then 16, 8, 4, 2, 1. Each time it goes through the loop. So that tells this to turn on one pin at a time as it goes from 0 to 7. Now what happens when there's a voltage coming back to the Arduino microcontroller, what this does in the code, it will then tell, depending on what index it's at, it's if the index, if the voltage comes back true on the, or as high on the as on that part of the index, what it will do, it will then put that index into an array of numbers which is stored. I've got an array of 8 numbers. But enough of the rambling about. What I'm going to do, I'm going to go on here and I'm going to actually, what I'm going to do, I'm going to get the code up. I've got the code right here. Right, what I'm going to do, I'm going to show you this. So I've got the actual code on the screen. Actually, what I'm going to do, I'm going to show you this part first. Actually, I've got these are the bits which are all switched on at the moment. Now I can pull out any one of these wires on the back. So what I'm going to do, I'm going to do that now, right? I'm not going to do each one because it's fiddly, but I'll pull out the third one along from the left. So when I pull this one out, you'll see that goes 0. If I pull out the one next to it, again, that's the first one actually, that's the first 0. As I said, like, I've got not very fiddly fingers, so I don't want to pull all these wires out, but it just shows that each one of these wires will do as it says on the tin, right? The position from left to right will change the left to right on this. Right, I'm going to show you the code, which I'm going to include all these files, including the circuit diagram, in the description. Now you have to excuse that blob of light because I've got what I've got is my flash on, but while it's in camcorder mode, it's crap. It does not give me the option to turn off this flash bulb during recording. So you're going to have to bear with me and put up with that. And I ain't got a clue how to do video editing. So I mean, I'm not a video person. I'm more of a project person, right? But anyway, I've got on here all the like pins, all like dedicated, like declared up on here. So that clock pin is pin 2, latch pin 3, data pin 4, and that yellow wire, which is the return wire, which is the input pin, is 5. That's the one that detects the voltage coming from the 10k and the bus at the bottom of the board. And then here's the right, actually this is a bit annoying. What I'm going to do, I'm going to take out, because this bit where it says page, that's actually not in use. So what I'm going to do, I'm going to take that out. Actually, no, I'll do this afterwards because I'm holding the phone and I can't really operate the shift key at the same time as the other key. What I'll do, I'll take out this integer page because it's no longer needed. That was for test purposes for my reasons, which I'm not going to go into because it's irrelevant. But imagine that's not there. But the flags in that array, that is supposed to be there, and they're all set to a 0, which they would all be if all the wires were not connected to it. So if you imagine them wires as being inputs from something else that wants to control it, that's what those wires are for. Like, you would actually take them out and the pins would become that side of each resistor. That would be all your pins. Like, I'll show you back down again. Like, you can just see them all here. These sides here, these will all be your input pins on these resistors. Now, I mean, I know I'm rambling again. Like, sorry, I'm a bit autistic, so like I do tend to ramble and I do lose track of what I'm talking about. But on here, what I've done, at the moment I'm using the serial monitor, so like I need to put serial begin, but you should know about this already. This is not an Arduino tutorial. I'm assuming you know how to use the serial monitor by using serial.begin, and I've set that up as 9600 baud. And what I'm doing here, the 3 clock pins, like the clock pin, the latch pin and the data pin, are all set up as outputs because they all put pulses out to the chip. And the input pin obviously is an input because that yellow wire here, this sends a voltage up it to that pin 5. So what's happening here in this loop, as this loops through, you would like again, I'm not going to go into this bit about the latch pin low, latch pin high. All that is, that's just so that, like, where you put it in one state to load the data into the chip, and then you put it into another state to actually get those out of the little memory slots. Like, the shift register is technically, like a 595 is technically 1 byte of memory, which when you latch it, it then puts all of the bits in that memory onto the 8 output pins. So what you do, you use the shift out command, tell it what pin you want it to go to, tell it what the clock pin is, tell it what order you want it to go. So I'm putting least significant bit first, which is the rightmost bit on the binary number. Then you put the next bit up to the 8th bit. And this bit here, 128, is the most significant bit. So it'd be this side of the binary digit, the binary number. And I suggest you look up how to use shift left and shift right. I'm using shift right here. But what it does, like I said, this loop here, like obviously you see the integer I there, which is this on the for loop, and when it gets to 8 it breaks out, so it's 0 through to 7. Like, as long as this condition is below 8, it will go through each one and then it will go back loop again. But you should know how to program this by now anyway. If you're studying inputs, you should already know how to program an Arduino to a certain point. But what I'm doing, each time that number increments, I'm shifting the bit to the right on the binary number. So on the 0 iteration it's 128, and then on the next one it's 64, next one it's 32, then 16, then 8, then 4, then 2, then 1. I hope I've got that right without missing anything out, but you should know this anyway. And then what it does, it then this array that I told you about at the top, what it does, it then in the current index number slot of that flags array, it puts the status of the input pin digital read into it, because high is 1 on this and 0 is low. I don't have to do if high then make it a 1, if low make it a 0. Like, you can just quite literally put high or low into an integer array, or an integer number for that matter. But enough of that. That is pretty self-explanatory, that loop there. Then I print the outputs. So I've got this little function here which just goes through each one each bit in the flags and then prints it side by side accordingly into a string and outputs it like to the serial monitor's console, and then puts a new line under each one, which is how you're getting these like that. But that's pretty much it, really. I mean, I've only done this just to prove a point that it can be done. I mean, when I actually get round, when I get these other chips back through the door, I mean, I've sent away for some 74HC595s. These ones I've sent away for another, I think it's about 20 or 30. I think it was 20 I sent away for. And they should be here sort of middle of the month somewhere. When they do come through, I'll do another video on how, on what I'll do. I'll document what I'm going to do. I'm going to actually make myself probably about a 32 pin output and input. What it will end up having is 32 input pins, 32 output pins. The 165s as the inputs, the 595s as the outputs. But that's for another video. In the meantime, I'm gonna wrap this up in a sec, because what I want to do before I do wrap this up, though, I want to show you the. I'm going to include this anyway. Now, what's happening here is this is the 595. You've got the first data line here, then that data line. Now you see this is how it goes from, say, pin 15 through to here, down here into the first transistor. All the time this pin is off, nothing flows into this diode, so nothing gets passed from this side of this 10k resistor, nothing goes up the wire. So this resistor then pulls that yellow wire low, so you don't get any floating light or any glitches. Otherwise, those little noughts and ones on that screen, they just glitch all over the place if you don't put that 10k resistor in now. So what it does, when that one's switched on, and when that pin's on and this transistor is on, it passes the current back along up the yellow wire back to the microcontroller, into this plug here. If not, it pulls it low, and then once it's done that one, it then turns off that pin, then turns on this pin number 1, and then that goes through the second transistor, and then it does the same again on that loop, and then it does the same for the third one, then the 4th, 5th, 6th, 7th and 8th. Like, include the 0, so there's 8 of them, even though that's pin 7. So it just switches each one of these little circuits on and off. And as I say, when each one's on, it has to, the code knows which one it is, because it's on that part of the loop when it passes something back, because that would be the particular pin that's on at the time as well. Now I'm hoping you all understood that, or most of you understood it. Like I said, I'm not very good at explaining. I'm better at doing something than. I mean, it's one of the reasons why I never became a school teacher. Not only that, I act like a kid anyway, so they'll probably mistake me for one of the students. So, like, anyway, what I'm going to do, I'm going to leave you with this. Before I go, back to these white wires, actually. See this black line here? I mean, that black line, that's where all your diodes are all connected together. And all of those yellow, red wires coming up on me, coming off the 5 volt, all of those red wires are actually these multicoloured wires here. I thought I'd better point it out, because these wires, I didn't have a lot of red wires laying around, so I just grabbed what wires I could at the time. But for simplicity, on the screen, like, believe me, these are red. Yeah, imagine they're red, and imagine these white wires here are that black bus wire there that connects all the cathodes together. on these diodes. And then of course the 1K resistors, like it's always this, the furthest away from the resistor is the input pin. You wouldn't normally have this red set of red wires. You'd normally, these be signals from whatever you're sending stuff from in order to make that do what you want it to do. But like yeah, going back to the program as well, the actual code, when you're using the code, obviously this print command, print inputs, would not normally be what you would desire it to do. You would actually replace this with what you want to act on based on this flag array here. So you do your own handling code to so that if whatever bit you want is true, is on or off, 1 or 0, then you tell it to do something in your program, which would then maybe send out something to another 595 chip, which would be an output, or even turning on another input or something like that, or controlling something completely different. Like, use your imagination. I'm not here to actually tell you what you can and can't control with it. My answer to that is probably pretty much anything that can be controlled. But yeah, I'm going to leave you with this anyway. It's the best I can explain this. As I said, it was just a fun little project, just for my own satisfaction, and to just show that I know that it can be done. Right, anyway, I hope I've not bent your ear holes too much. Right, thanks for taking the time to listen to this video. Go ahead and build it, and feel free to ask questions. I'll try my best to answer them. Maybe if you can elaborate on what I've done here, if you can think of anything better I'd like to know about it, I'm sure that other people would. So I'm encouraging you to build this circuit and improve on it if you can. Right, thanks for listening, and until next time, I'll catch you lot later. Bye bye for now.